All right, welcome back. We finally have a video with Bitcoin in the title. So if you skip to this, well, you found the right video to skip to, I guess. But also,
I'm Kevin. This is Cole.
Yeah, we did talk about some important stuff in the past couple videos. We first talked about the different types of money, 3 different categories that most economists recognize. We talked about this weird sort of fourth gray area type of money, which is a digital currency, like the in-game currency in World of Warcraft, or the, what is it? IS something?
Interstellar credits.
Space credit. Oh, just interstellar.
Space credits.
Yeah, and EVE
Space
Online.
money.
Anyway, and then there's another group that we're going to talk about, which are cryptocurrencies. And we've already talked about B-Money and BitGold briefly in the last video. Now we're going to really focus on Bitcoin. It's not the only cryptocurrency, but it's the one we're focusing on for the most part. We'll talk a little bit about Ethereum as well.
We're going to use them interchangeably in this course because most people are going to be most familiar with Bitcoin. But in general, when we say Bitcoin, a lot of these concepts extend to all cryptocurrencies.
Right, but we'll be pretty clear on what's specific to Bitcoin as well.
Yeah.
So what is a cryptocurrency?
A cryptocurrency uses cryptography to do 2 things. 1 is prove the integrity of its ledger, and 2 is to prove ownership.
So wait, we're getting ahead of ourselves. What is cryptography?
Cryptography is the science or the art of sending secret messages.
So the simplest form would be, using a decoder ring that you got in the back of a cereal box to encrypt a little message and send a note in the back of the classroom.
All the way up to RSA or the Enigma machine and different states of the art of encryption.
Well, and a lot of things that Bitcoin uses, actually.
Yeah.
Some of them are pretty complicated and force us to devote a lot of time to teach them.
But we're going to cover them. And
okay.
We're going to hopefully cover them in a way that even if you know nothing about cryptography, we'll shed some light on what's going on here.
Yeah. So that's where the crypto part of cryptocurrency comes from. Okay, so we have another nice definition here to read out. Take it away, Kevin. You're so good at it.
Bitcoin. I'm good at reading. Bitcoin is a peer-to-peer payment network that is powered by its users and governed by a combination of cryptography and social consensus.
Okay.
Voila.
So peer-to-peer payment network is powered by its users and governed by a combination of cryptography and social consensus. That's basically a way of saying that there is no centralized authority. The authority is the consensus of 10,000 plus users agreeing on transactions in the history of what has happened.
And cryptography to actually reinforce that consensus.
That's the lock on it. A very fancy lock.
In October of 2008, this paper was pseudonymously published by someone, a group of people, one person, he, she, we're not sure, was anonymously published
it wasn't anonymous.
But sort of anonymous.
Name. The name given is Satoshi Nakamoto. If it was anonymous, they would say anonymous.
Okay.
It's a pseudonym. Kevin and I have been disagreeing on this.
By someone who went by the pen name Satoshi Nakamoto. That's October of 2008. Now, in January of 2009, the network described in this paper started running on Satoshi Nakamoto's computer. And on January 3rd, 2009, the first Bitcoin block was mined.
We haven't talked about what blocks are, what mining is, and we're not going to right now. But just know that happened in January 3rd.
Yeah, that's the first entry in the Bitcoin ledger was on January 3rd in 2009.
Basically, the first Bitcoin was created.
Yeah. On January 12th, 2009, was the first transaction between 2 people, or if Satoshi Nakamoto is an alien, we're not sure, between Satoshi Nakamoto and Hal Finney. 10 Bitcoin were sent from the address commonly associated with Satoshi and Hal Finney, and you might recognize the name Hal Finney. That's the person who invented reusable proof of work, the catchily named reusable proof of work.
Reusable proof of work
that we mentioned in the last video.
Okay, so that's the rough timeline for Bitcoin.
Mm-hmm.
So after the paper was published, after Bitcoin was created, it took a little bit for it to catch on and get any value.
Yeah, people started using it. There were people on forums online that were actually running Bitcoin nodes and creating and maintaining the Bitcoin network, but it didn't have any real value until May 22. So on May 22, 2010.
Okay, wait, I want to read this part.
Okay.
This is exactly...
You gotta read it verbatim when I've written on this slide.
This is what we have written down. On May 22nd, 2010, a developer bought 2 pizzas using 10,000 units of a then little-known digital currency called, you'll never guess, it's called Bitcoin. Yeah.
my writing.
Okay,
Good,
it's
huh?
excellent writing, Kevin. So this was important because this is the first instance of somebody using Bitcoin for something real. And at the time, it was 10,000 Bitcoin, which, wow.
So that would be at the height of Bitcoin as of 2018. That would have been $200 million.
So at that point, Bitcoin had an actual value. It still wasn't very high, but it took 10,000 units to buy 2 pizzas. But over time, I think around 2014 is when Bitcoin started to approach the $100 mark.
Yeah. Give or take.
Yeah. And then here's a chart of 2017 into 2018. Obviously, a lot of growth, and then also some
A little bit of a crash.
not so much growth over here, but at one point approaching $20,000 per Bitcoin. I mean, in that year, starting at under $2,000 to $20,000, it was a pretty crazy year.
Yeah, we're going to refrain from commenting on the actual value of Bitcoin here, and because in general, this course is more about the underlying implementation, the technology, what blockchain has to offer. Bitcoin may disappear, but the technology that it represents is likely here to stay. So we're just showing this slide. We're showing the price here to demonstrate that this is something digital and decentralized that does have real value. People are paying up to $20,000 per unit for this thing that was created based on this paper written in 2008.
Okay, so returning back to this definition that we have, peer-to-peer payment network that is powered by its users and governed by a combination of cryptography and social consensus. The social consensus part in particular is what we want to talk about now. So if we go back to a really simple example of Rainbow Coin, but we've implemented it like Bitcoin. It's decentralized, and we have 4 ledgers now. Here's a transaction. Kilgore wants to give Montana 1 Rainbow Coin. That's great. We can record it on a single ledger, the closest ledger to whoever Kilgore is, I guess.
You tell your nearest ledger keeper, I, Kilgore, would like to send 1 Rainbow Coin to Montana.
But the trick of all of this now is letting all of the other ledger keepers know. And that can be difficult to make work and keep things in sync, but basically the goal is that everybody finds out about it.
Clip art arrows.
There we go.
More clip art arrows.
And everybody should agree on it, unless there's something fraudulent going on, and we could identify it at that point.
And we're going to cover the idiosyncrasies of this process, but what you're looking at here is effectively what goes on when you decentralize a ledger. You tell a nearby node, and then it propagates across the network.
Yep, and they're constantly communicating with one another. Basically, hey, did you hear about this one? Did you hear about that one?
Yeah.
Did you hear about that one last night?
So one thing to note about this picture is that this happens over time, and it's hard for people to grasp, but the idea of Bitcoin being governed by social consensus means that there's not a finite moment in which your transaction has happened. It's based on when most of the network agrees on your transaction. When you send it to a nearby miner, it's not necessarily immediately done. You have to wait until the network has accepted it. And hypothetically, more than 50%. In general, we look at more than 50% being the benchmark for when a transaction is complete.
And one really odd side note that we didn't have a good place to put.
There's nowhere to put this slide.
So we're putting this in this. It's not enough for its own video, but this is a slide that talks about the divisibility of a Bitcoin. So nowadays, a Bitcoin is, it's worth thousands of dollars. And most people aren't, in typical day-to-day transactions, aren't dealing on a scale that large.
Unless you're buying coffee in San Francisco.
Wow, that's a very funny joke, Kevin.
Here all week.
Unfortunately, that's true. I'm stuck with you. So
1 Bitcoin is 100 million Satoshi.
Right,
so
and that's the smallest unit, which it's a little egotistical. I mean,
I don't know if he named it or they named it, but it's called a Satoshi. 1 unit of a Bitcoin is called a Satoshi. And what that means is if you want to buy Bitcoin, and we're not saying that you should do that, you should wait until a little bit later until you know a little bit more about what the implications of buying it are. But if you want to buy some, you don't just have to buy, it's not a minimum 1 Bitcoin. You can buy 100 millionth of a Bitcoin. The fees would be way bigger than what you would just bought. That'd be a terrible idea, but it's very easy to buy 0.1 or 0.01.
Right. And that's pretty much it for this slide. We just need to stick it somewhere.
Yeah. Voila, done.
Speaking of acquiring Bitcoin, in the next video, we're going to talk about some of the ways that you can go and do that. All right, welcome back. We talked about Bitcoin, we introduced it. What we're going to do now is talk about, in broad strokes, 3 different ways that you can acquire Bitcoin. And this is not going to be a tutorial, a step-by-step guide on what you need to do to buy your Bitcoin right this second. We will have more detailed instructions, but we're not going to give any investment advice, by the way.
No investment advice.
But we need to talk about this to understand how Bitcoin works, actually. So there's 3 ways we're going to introduce. And the first one is to purchase Bitcoin at an exchange.
Yeah, ranked in order of the easiest to most difficult. So
Right.
the easiest way is to just buy it at an exchange.
So what's an exchange?
What's an exchange? An exchange is a private organization that exchanges cryptocurrency for other currency: dollar, euro, yen, peso, etc.
Right. Well, and actually an exchange, there's plenty of exchanges that have nothing to do with cryptocurrencies.
Yeah, foreign currency exchange.
Yeah, you want to exchange your US dollars to pesos, for example, then you can do that online, you can do that in person. But with cryptocurrencies, there are many, I don't even know how many today there are.
Oh, there's a ton of them. Yeah.
Tons and tons of these organizations that you go onto their website or you download their app on your phone and you sign up for an account. You hook up a credit card or bank account or somehow deposit money from US dollars or euros or whatever currency you have into the exchange, and then they give you some amount of Bitcoin. And we're just going to talk about Bitcoin, but some of them support other types of cryptocurrencies.
Yeah, and they typically charge a fee.
Right. So it's super, super easy. It's as easy as, sometimes it's annoying. You have to get verified, or you have to, take a couple steps along the way. It's not as easy as just buying a book on Amazon, for example, but it's almost that easy. You put in some information and you get Bitcoin. So it's easy, but that comes at a cost.
So the risk here, and the problem with exchanges, is that they're not decentralized. That means that exchanges are subject to the regulation of the jurisdiction in which they run. They're much easier to trace. So when you're signing up, you're giving them typically your driver's license or some form of identification that associates you as a person with what you're buying. And last but not least, they lack the security guarantees of the Bitcoin protocol. Bitcoin itself is decentralized, but exchanges are private organizations. They're centralized and they're subject to all of the problems that we discussed when we talk about Rainbow Coin.
Yeah, so we want to be clear. It still is Bitcoin, right? The Bitcoin itself is not the problem. The problem is that if you buy it through a company, whatever the company is called, Kevin's Exchange.
Kevin's Exchange is a good one.
I create my account. I give him my money. He gives me the Bitcoin. By default, the Bitcoin is still held by Kevin, basically.
I'm going to hold this Bitcoin for you.
And he just says, this is yours. I know this is Kevin, or this is Colt's Bitcoin. Mm-hmm. But he still is the one who is in charge of it. And that's how most of these exchanges work. That's what makes them so easy. You don't have to do any setup or any of the difficult work to get it into your possession. You just create an account with them and they hold it for you. But that kind of gets back to the whole problem with Rainbow Coin, which is Kevin could be a charlatan, to go back to that word.
I'm a charlatan.
Kevin could be deceitful. He could be trying to scam us, or somebody could hack into Kevin's site and he could have the best intentions, but they could steal the Bitcoin.
I become the single point of failure.
Yes.
And so now we're going to discuss the cautionary tale that is Mt. Gox.
Okay.
So Mt. Gox was an exchange that was established in Tokyo in 2010. So this is about a year after Bitcoin was released. And by 2014, it was handling 70% of all Bitcoin transactions.
Yeah, it became massive. And in today's world, it's definitely more fractured. There isn't a single exchange that has such a massive share of the market.
No, there's no longer such a monopoly. But with that monopoly, in February 2014, 850,000 Bitcoin was stolen. And at the time, that was $450 million.
Nowadays,
that'd be what? If we think of Bitcoin, the stat we'll use is $10,000 per coin, that would be $8.5 billion.
Right.
It's a massive heist. And
this was all people's Bitcoin. Like they had bought it with their own money and the exchange was holding it for them and associating it with their accounts, and it disappeared overnight.
Yeah, so they would log into the website. It would say you still have the Bitcoin, but they just could no longer withdraw it. And this is the problem with Mt. Gox being that single point of failure. It was hacked, or it's still not certain. We're not going to comment on whether or not.
Some people think it's an inside job, and there have been ongoing legal proceedings about it.
Yeah, and if you're curious, Mt. Gox, MTGOX is the way that it's spelled. If you search that, there'll be tons of articles. But in March 2014, they declared bankruptcy, and this actually really tanked the price of Bitcoin. People really lost faith in Bitcoin, and this is a common misconception. People think that because Mt. Gox was hacked that Bitcoin was hacked. They're entirely different things. Mt. Gox was just a custodian of the underlying cryptocurrency.
So now that we've talked about how terrible some exchanges can be or some of the shortcomings, we do want to mention, though, that it is a very accessible way of buying Bitcoin. It's how probably most people buy their first.
Yeah, most entry-level people are going to buy Bitcoin this way.
And so exchanges are something that you want to have faith. You want to be able to trust. Mm-hmm. And there are so many of them out there. We're not going to endorse any particular exchange, mm-hmm. but on Bitcoin.org, if you go to...
So this is the Bitcoin Foundation's website. This isn't even necessarily Bitcoin itself, but many people look at Bitcoin.org as the sort of de facto authority on Bitcoin.
Right. And so they have a list on here of recommended exchanges, but they still have a disclaimer: perform your own due diligence. And they tell you this note that we'll come back to: choose a wallet where you will keep your Bitcoin. So what they're telling you is use an exchange to buy it and then move it from that exchange into your control as soon as possible.
And we'll cover what a wallet is in the coming chapters. But if you look through this list, you'll also notice some of the well-known exchanges are not on here, and that's because Bitcoin.org is engaged in the politics of Bitcoin. They've removed some of the exchanges that, in this case, I believe it's because there's a fork of Bitcoin. We'll describe that later. There's a faction of Bitcoin called Bitcoin Cash, and I believe that Bitcoin.org has removed any exchanges that support this other version of Bitcoin. So if you're interested in buying Bitcoin, it's important to do your due diligence. Just a few Google searches. If you can navigate the internet and do your best to not get phished, then you're probably well equipped enough to make a decision on where you want to spend your money and understand the risks.
So the next way, the next option of acquiring Bitcoin is to exchange it for something. So person to person, peer to peer. I sell coffee. I am a barista. Kevin comes in, he decides he wants to pay for it with Bitcoin. He can send it to me, not through an exchange, but through some sort of app. He can send it to me through an app on his phone or on a computer, pretty much anything these days, any electronic device that can connect to the internet. There's a way
that adheres to the Bitcoin protocol.
Yes.
Yeah.
And so we download an app. It doesn't really matter which one. We'll talk about them later on, but we both have an app. And I basically tell Kevin where to send a Bitcoin to, and then he inputs the address where I told him to send it to, how much to send, and he hits send. And that's kind of it. But there's actually a lot more behind the scenes, and we're going to do a whole video actually showcasing how this works, demonstrating it step by step. And Kevin's going to send me 10 Bitcoin.
Colt's going to send me 1 Bitcoin. 0.1 Bitcoin.
Okay, you're going to send it to me, though. Anyway, so that's one way of getting Bitcoin. So the third way of acquiring Bitcoin, definitely the least intuitive, the least approachable, is to generate Bitcoin to get it through mining. Mm-hmm. So mining is basically the way that new Bitcoin are created or found, just like with mining gold. A lot of people go out and they don't use pickaxes anymore, but
pan for
all
gold
sorts
in
of machines and crazy equipment, but they all mine, they try and find gold, and some people do, and they're rewarded for all that work. So in the world of Bitcoin, it's an analogous process, except rather than hitting a rock over and over and over, what are they actually doing? What's the point of it?
So we're gonna explain this in greater detail in the coming videos, but miners are the people who maintain the Bitcoin network. So the competition is quite complicated, but really what's going on is, for maintaining a copy of the ledger and for facilitating new transactions, you gradually earn Bitcoin.
Right. So computers are hard at work behind the scenes, and some of them are rewarded with new Bitcoin.
Yeah.
Okay, we'll get into a lot more detail. We have a whole section on mining later on.
Oh, there's plenty more there.
Okay, so those are the 3 ways of getting Bitcoin. Remember, the first one, an exchange, is the easiest, most approachable way, but it also has the main shortcoming of relying on a single point of failure. You can also exchange Bitcoin. So you could do something, someone could send you Bitcoin, or you can send Bitcoin to someone else. And then finally, you could get Bitcoin through mining. Welcome back. So now that we've talked a little bit more about Bitcoin, we're actually going to revisit the analogy that we did in the first couple videos of the course. It was a pretty quick, couple-minute analogy, basically meant to just quickly explain some stuff. So we're going to expand on that previous video in preparation for the next video when we actually make our first transaction. Okay, so back to this Dropbox envelope thingy. What we're talking about here is the idea of a one-way place where somebody can send Bitcoin to. It's called an address. and we're picturing it as this little envelope logo or clip art with this QR code, but in actuality, it looks something like this.
So that's a real address. Don't send anything to it.
Well, I mean, it wouldn't
Or
be...
do, but you're not
nothing
gonna...
bad could happen except that you're going to
You
lose
can't
that
get
Bitcoin.
it out, yeah.
Right, that's the point, is that you send something to this address, it's in there, unless you are the owner, the creator of that address who has the private key, which we'll show in a second, to unlock it. We'll discuss how these are generated, what they mean later on, but all you need to know is that you can make these on all sorts of applications, a phone app, a computer app, at will, if you want someone to send you something. You just give this to them. So an address is used to receive the payments, and at the same time, when you generate a new address, you also generate a private key. So you don't really have to do anything, you just click a button most of the time, but you get these two things. And the private key is what you use to unlock the payments.
So on the left is the address we just saw, and on the right is an example private key. They don't correspond to one another.
Yeah, so this is not...
Or maybe they do, but these are from the Bitcoin wiki.
Well, that would be a freak. I mean, I doubt it.
I doubt it, yeah.
But this is just an example of what a private key would look like. So both of these are very ugly. They're not very intuitive or memorable at all.
No, not user-friendly.
So most people use an app to manage this. But there's nothing, I mean, I could handwrite this and give it to Kevin and say, this is my address. Keep track of this, type this up. But most of the time we use an application that can scan a QR code or something to prevent, having to... It's hard enough to tell somebody your zip code or your phone number.
I don't even know what my zip code is.
What? Let alone trying to tell somebody this. I mean, it's just too confusing to try and read this out loud.
So the QR codes that you'll see in Bitcoin apps, those correspond to this number you see on the left, the addresses.
Okay, so here I have this same diagram of my phone. I'm creating these addresses at will. I make one anytime somebody wants to send me something. Now, technically, we'll get into this later. You could just have one address and have everybody send everything to that, but it's a better practice to make a new separate address every single time, and we'll talk about why.
Yeah, it still works, but there are some safety and anonymity guarantees that you get that you don't have when you're using the same address for every payment.
Yeah, long story short, it's harder to trace if you have a different, unique place where your money is being sent every single time, rather than the same place over and over and over. Just like if I was a drug dealer and I was getting shipments of cocaine from Colombia, I wouldn't ship them all to the exact same P.O. box. I would spread it out.
Yeah, good analogy, Cole. I hope we don't offend anybody with that.
Okay.
Can you actually say that in this?
Wait, why couldn't I say that? Okay, so Kevin's actually going to send me Bitcoin now. I make him an address, as we discussed. Most likely, I show him my phone. He scans a QR code, but I could also hand type the address out or read it to him over the phone, whatever it is. He finds a way, uses an application on his phone or computer to send however many Bitcoin he's going to send to me to that address. And what happens once that Bitcoin is in there? And what if you send the wrong amount?
So if I were to type the wrong number in and hit send, confirm it, then I would be able to I would not be able to undo what I had just done.
It's locked.
I would have to go to you and say, Colt, please return my Bitcoin.
So yeah, he puts it in there. Anybody can put Bitcoin in this address is the thing. So if I also sent it to everybody, all my friends, and I said, hey, please donate Bitcoin to this for my scholarship fund or something, anybody could send Bitcoin to that, but nobody can get it back out. And that's a good thing. That sounds very sinister, but that's important. I mean, it's just like a bank. You could transfer money to a bank account, but only the owner can decide where that money goes or transfer it out.
Yeah.
Okay.
So once I've put Bitcoin into the address, or once I've locked it into that Dropbox, what I do is I deposit that Dropbox onto the blockchain. I store that in a public place, and Colt just keeps an eye on the blockchain.
So what is the blockchain actually? When we talk about it, this is a diagram of colorful blocks, but it's just a list of transactions.
It's
right?
a big ledger. Yeah.
Yes, it's a giant ledger. Now there is some sneaky, interesting math involved in the chain part of it. And well, actually, the block and the chain components we'll discuss later on, but it's more than just a list of transactions. There's a special mathematical relationship between new transactions and old transactions, and there's a bunch of security benefits, and we'll talk about it.
It being a blockchain makes it tamper resistant.
But for now, all that we care about is that it is a place that stores a history of transactions. So on the blockchain, you can see every Bitcoin transaction in history. Ever since you can go back and see the very first transaction in January of 2009.
Mm-hmm.
So the thing is, there's not one single blockchain really. In actuality, there are copies of it across 10,000 plus computers across the world.
Yeah, all of the miners, the people we discussed earlier on in how to acquire Bitcoin, keep a full copy of the blockchain. So when I put Bitcoin into a Dropbox, I send it to a nearby miner, and they actually share that information with the other miners. And Colt can keep an eye on any individual miner or any individual subset of miners, and that will give him an indication of all of the incoming transactions towards addresses that he has created.
So as you can imagine, there's a lot of work involved in just keeping all 10,000 plus copies synced together and up to date and all of that.
And we're going to cover how that works.
Yes, but at the end of the day, to wrap up our analogy, which honestly has veered away from being an analogy to just
now we just went into it.
Yeah, just intro to Bitcoin. But this ledger, this idea of the blockchain that is distributed across all these different computers is huge to Bitcoin. That's the central building block that everything stems from. So once my transaction is on the blockchain and it spreads across the majority of the network, everybody agrees that this is a real transaction. It's not totally made up, or Kevin has the Bitcoin he's claiming to send me. All of that checks out. Then let's say, it could be a matter of the next day or an hour later, I want to spend it, or it could be 5 years later. I forgot that I had Bitcoin in this address. I forgot Kevin sent me Bitcoin. I forgot Kevin exists. I erased him from my life.
That's
and
hurtful.
Then a couple of years later, I see a news story on Bitcoin, and I'm like, oh
yeah,
I totally have some, don't I? And I go back and I have to find the private key. But if I do find that private key, I can go unlock this one transaction, this one address.
So when people say that they have Bitcoin, nobody actually has it in their possession. It just means that people have the private keys associated with transfers destined to them. It's all sitting on the blockchain, and you don't have to spend it immediately, but when you do want it, you know that you have the private key associated with your Dropboxes, with your addresses.
Yeah, it's pretty weird. There's nothing on your computer or on your phone or stored on your, in your data that actually means or signifies that the Bitcoin is yours. It's this public thing, and you just have to show proof that this one section is yours, or that you own this one little piece.
Yeah.
But you could, your house could burn down. I hope it doesn't. But if it did, and you lost all your electronics, as long as you have the private key somewhere, you somehow have managed to save it, whether it's in the cloud or you have it on a hard drive that you have buried in the backyard or something. If you have that private key, you can go to any computer. You can go to basically anywhere that has internet and prove that you own that Bitcoin.
So, and with this analogy, when we talk about how people have, or when you hear that people have had Bitcoin stolen from them, or when you hear that an exchange has been hacked, it usually means that the keys associated with an address have been stolen. Nothing physically has been taken. It's just this information has been leaked or taken.
Right. Okay. So that's it for now. I'm calling it quits on this video. This was
cut.
Yeah, this is pretty in depth. So next, we're actually going to show a transaction. Kevin is going to send me Bitcoin, and we're going to go through these steps, but in real life, not on slides with clip art. Real Bitcoin. So that's coming up next. All right. So we're finally going to do a real transaction. Kevin is going to send me 7,500 Bitcoin.
I got you, fam.
He's going to make me an overnight multimillionaire. No, he's going to send me a tiny little, what do we decide?
I'm going to send you a millibit, which is 1/1000th of a Bitcoin. No, not even that. I'm going to send you 1/10 of a millibit. I'm going to send you like $8.
Okay. So he's going to send me a tiny little piece of Bitcoin, but the same process would hold true if for some reason he wanted to send me thousands of Bitcoin. Yeah. All right. So really quickly recapping, the first thing we need to talk about, we're going to use iPhones to do this. We could do this from computers, from Android devices, from Windows phones. It doesn't matter. But we need to download an application to help us do this. And there is no official Bitcoin application. There are dozens and dozens of apps on the iPhone App Store, on the Google Play App Store, and so on, that all basically follow the same Bitcoin protocol. They follow the rules. And there's no one official app.
So they're all third party, which means Satoshi Nakamoto didn't make any of these. It's just people who built applications that adhere to the protocol.
Yeah. And so we're going to do a section later on about talking about picking out a wallet app and kind of getting up and running. For now, if you want, you can download the ones we're going to use, but we're not necessarily encouraging you to do that because there are so many out there. We're just using two that we have on our phone already. And so I also mentioned we're using two. Kevin has one on his phone that he's going to use to send me Bitcoin. And just to prove to you that they all work in the same way, I'm going to use a different app to receive the Bitcoin. We could use the same one, but we also didn't want to endorse one over the others. So I'm going to use the app to create an address or many addresses. And each address has an associated secret private key that I need to use, or the app needs to use, if I ever want to spend the Bitcoin. So an address looks like this.
So these are the three representations of an address that you'll see in our slides. On the far left is a real one. This is the base 58 encoding. It's the text encoding of an address.
Yep.
And you'll see this in the wallet app once we open it up. In the middle is a QR code, and the QR code is an easier to use camera scannable representation of what you see on the left.
Yes.
And then on the right is our analogy. It's the open Dropbox. It's an open envelope. And our thinking here is that this looks like something that you could put something in and then you could lock it. And then once somebody locks that Dropbox, only the person who created it can then open it.
Yep. So Kevin could type this in manually. There's nothing wrong with that, except that it's slow and annoying, especially on a tiny iPhone keyboard. And also, it's technically possible that he typed something wrong and it's actually someone else's address. And we'll talk about that. It's unlikely, but it's possible that he changes some characters and it's actually someone else's valid address. And the second thing that a wallet app will generate for you, along with your address, is a corresponding private key. And that private key is super important. You don't want to go sharing that with anybody. You want to keep that safe and secret. Most of the apps won't even show it to you because they kind of handle it all behind the scenes. But yes, it looks something like this. So it's just another long number, as you can see here. And this corresponds only to the address that it was generated along with. And we actually spend a lot of time talking about how these are generated and the math behind it later on in the course. Just know there's a special relationship. So this number unlocks that address, which, if that sounds crazy to you, just suspend your disbelief until we get to that section, because it's pretty mind-blowing how it works.
Here we go. Now we're going to show you an actual transaction.
Okay.
Much ado.
Switching over to screencasts. All right, so you should now be seeing two phones on your screen if I did my editing job correctly. The one on the left is Kevin's phone, and the one on the right is mine. So remember, Kevin is going to be sending me the Bitcoin. He already has Bitcoin. Let's not worry about how he got it. We're just going to focus on this transaction. So he has some Bitcoin, and he's going to send it to me. The first thing I need to do is give him a place to send it to. So the app I'm using, by the way, is called Blockchain, which is kind of confusing because blockchain is also a really important concept in Bitcoin. Completely unrelated. Well, the name is related, but they have nothing to do with one another as a company or as a corporate entity.
Completely confusing.
Yes. Anyway, so I'm using this app. Kevin on the left is using a different app called BitPay. Now, we could be switched, and I could use this app to send him Bitcoin. He could use that app to receive it. It's not a one-way thing where you have to have one app to send, one app to receive, but we're just using two different ones just to show you that it works.
Yeah, both of them are our window onto the actual Bitcoin network.
Okay, so what I'm going to do now, I'm going to go to the request tab of my application. I already have it open. And it gave me a new address already. It generated it for me. So if I use this one, I'll actually show this later. Once I do use this, it will give me a new address, a different one. Anyway, so what I'm going to do now is share this address with Kevin. The private key is behind the scenes. It's associated with this address. It's kept secret, but it's in the phone. My app is keeping track of it for me. All right, so I could read this to Kevin. 1G15. Are you ready, Kevin?
Yeah, I am not about to type this. We're going to use a cool feature that says scan. So
right.
Colt's going to put his phone on the desk, and then I'm going to hit scan, and I just point it at Colt's phone. So you can see this is going to Colt's nice desk, and then I point it at Colt's phone. Voila.
All right.
Okay, so now I get to, this is Colt's address up here, and just to confirm, I'll ask Colt, hey Colt, does your address start with 1 capital G as in golf, 15, H as in hotel, K as in kilo, P as in
Okay, I'm going to stop you
potato?
there. Yes, it does, Kevin.
All right, then I'm going to send you 0.0001 Bitcoin.
All right.
98 cents. I got you. Send.
Okay.
Now, it's actually not sending yet. It's calculating a fee. Oh, and it says Bitcoin miner fees are unusually high. And this is because, oh, interesting, we have limited space on the Bitcoin network. So because the price is spiking right now, who knows where it'll be when you are watching this, it means that there are fewer spaces on the blockchain. And in order to get my transaction included into a block, I have to pay a little bit extra fee. What's that come down to? Oh, that's fine. 40 cents of a fee, I can live with that.
Yeah.
So
Or
I'm
you
gonna-
could wait and pay a lower fee and it would eventually make it in. It's just that we're recording a video, so we need this to happen sooner rather than later.
Yeah, look at this. I can even tune how much fee. I can do urgent. That means I'm willing to pay way more. How much would that cost? Apply changes. I understand. Oh my God, $2 for an urgent transaction? Let's do it because we're doing this live.
Okay.
So we're paying $2 to send like 90 cents of Bitcoin.
As a side note, we have a video on this where we talk about block sizes and transaction fees and how that all works. So you can see now that it's a fact of life in Bitcoin, but as far as the network being overcrowded and what that means and how that relates to fees, we'll explain that later on in the course. So Kevin right now is having to type his password. So hopefully if I did my job right, again, we're editing that.
All right, so here goes nothing. Yeah, you could definitely see this. Can you just block half of it out?
I'll
I
block
hope
it
so.
out.
Let's try this. Sending, signing, voila.
Okay. So Kevin typed his password in. It showed that it was sent. Okay, so you sent it. Does that mean I have it now? Is it mine?
You don't have it yet.
Are you sure? It says, I got a notification right here. Payment received, 0.0001 Bitcoin, 98 cents.
So that's just indicating that it sees an incoming transaction. You have to wait until that transaction is confirmed by the network. And let's go look at let's inspect the transaction.
Okay, so if I go over to my transactions, we can see that there's a new one here that said received, and it says down at the bottom, pending. So it shows my phone knows about it now. This app knows about it because it's basically out there on the network, but it hasn't been officially added to the blockchain. And you can see 0 out of 3 confirmations. What else? You can see who it was sent from. So this was Kevin's. This was the Bitcoin address he had Bitcoin in that he sent it to me from. You can see the value when it was received, currently 98 cents. Who knows? It might probably, well, it would be different probably in an hour.
$1 million.
And also, there's this thing down here, viewonblockchain.info. So what this will do is if I click on it, it will take me to a website that will show me the blockchain, information about my transaction. So I'm going to do that. And if we look at what it says here, we can see the address that it was sent from, and we can see that it says unconfirmed transaction. So it's going to take a little bit. But eventually, we'll cut back to this and we'll see that it has been confirmed and that the Bitcoin is considered mine. Currently, it's not mine. It's sort of in the ether in this, well, I shouldn't say ether because there's Ethereum is a whole other currency. But it's out floating around waiting to be officially recognized because potentially Kevin doesn't have the Bitcoin or the network is down or something could happen where...
Yeah, we'll talk in a later video about what I, as the sender, could do to, in a way, steal it back. You typically, in the Bitcoin network, it's a rule of thumb that you don't spend your transaction. You don't consider it sent until it's confirmed.
Okay. All right, so let's cut now and we'll come back once it's finished. So it's about 10 minutes later. I guess the official times on the phone will actually tell how long it's been. But what we can see now is that my transaction is still pending down here at the status. I guess, I don't know if this is showing up where I'm clicking. Anyway, it says pending, but now there's 1 of 3 confirmations. So remember in the one video ago, we showed this where the transaction itself is added to something called the blockchain. It's just a list of transactions. Looks something like that in our animation. Well, what has happened now that I see 1 out of 3 confirmations, this tells me it is actually on the blockchain now.
So a note about confirmations. When you see confirmations in an app like this, what it means once it is confirmed is that my transaction is now on all of the miners' computers.
Yeah. So what I'm going to do, I could click on the phone and do this. And this is one website called blockchain.info that allows me to view the blockchain. Remember, it's a public thing. Anybody could build a website that interfaces with it. All it does is display information. It's not changing anything. It's just purely looking at this blockchain, this super long list of transactions, and just showing it to us.
Because it's all public.
So rather than doing this on the phone, where it's a small screen, I'm also going to show you that we can do the same thing on the computer. You could do this yourself and go back and look at this transaction in history if you wanted to, however many days or years later you're watching this. Okay, so what I can see on this website, if I scroll down, it tells me a bunch of information about the transaction. We're going to learn a lot more about this later. But what I want to point out is this little bit here, included in blocks, and then it gives us a unique number for a particular block. And we haven't really talked about blocks, but this is just a division of this chain of blocks. It's a division of this long chain of transactions. 521259. So I'm going to show that on my computer, I'm going to go to a different website. I could use this blockchain website, but I'm actually going to use a totally different website called btc.com. There's another one that's popular called the Blockchain Explorer. It doesn't matter. And I can see here a list of latest blocks. And I'm going to come down to this one, which matches that number we had talked about, 521259. And this is now going to load all the transactions. Did I click on it? This will now load all the transactions in that block. So you can see here that there are 2,115 transactions, just like mine, probably different amounts of money and different addresses, of course, but they're all in this one block.
And the number of transactions that fit in a block varies because transactions aren't all the same size. It's how many transactions fit into 1 megabyte, and in this case, 2115.
Yeah, we have a video on that coming up, but you can see some of them just look larger. There's more addresses in or more addresses out. But that's all we'll say about it for now. So what I could do, I could type my entire address up here and search for it, or I could do a Command F. All I'm going to do, I know that it starts with 1G1. This is not the most efficient way of finding it. This is not my address here. This also starts with 1G1. But what I'm going to do is just cut to it. We've already found it. I think it's on page 7 here. All right, here it is. We're on page 5. Took us a second. It would be easier, honestly, to just scan a QR code and view this on your phone, or type this in manually or copy and paste the address if you really wanted to search for it. But we just did an old-fashioned Command F for 1G15. Here it is. So what you can see is this is Kevin's address right here, 19QPY. He sent me, what was it, 0.0001 Bitcoin. This is my address. Now, we'll talk about the second address later, but briefly, all that you need to know is that Kevin had other Bitcoin in this address he didn't send me. He had 0.0079 something Bitcoin. He only used 0.0001.
I unlocked that Dropbox, and instead of putting the change back into the original Dropbox, I actually create a new one. So to get my change back from this transaction, I just create a new destination.
Yeah, and his phone did all of that for him, his app. But this is Kevin's address up here. Both of these had to do with this transaction. This is the one I gave him to send me Bitcoin to, and this is his that was generated to hold his change. But that's all we'll say. But you can see it. It's now here on the blockchain. It's public. You could come visit this at any point. If you wanted to find this quicker, you could just search for this. This is a really long thing to search for, but this is our transaction. It has a unique identifier. You could go to this exact block number and just do what we did. You don't really have to spend time doing this anyway. It's not that interesting. But just to show you, you could see this. So once it has 3 confirmations, and we'll talk about what that is later, which if we cut to my phone, we can see it now does. It's officially confirmed, and I can consider that Bitcoin mine. Everything is kosher. There was no fraud involved. I have the possession of the Bitcoin, which really just means I have the private key on my phone to spend that Bitcoin. Everyone can see that address has it, but nobody can spend it unless they have my secret private key.
So if I were buying coffee from Colt for Bitcoin, then it would be safe for Colt to give me the coffee now.
So that process, it takes a little bit of time, and that's actually one of the complaints people have about Bitcoin that other cryptocurrencies attempt to solve. We'll see that later in the course. But for now, this is what we're stuck with, and it works well. It just sometimes takes longer than you'd expect. As you saw, we had to pay a little bit of a fee as well. But it's done now. I have the Bitcoin, and this is the same process whether we're talking about 1,000 Bitcoin or 0.00001 Bitcoin. So what we're going to do now, we're back in the slides, is we're going to discuss basically what happened post-send. So in the previous transaction, Kevin sent me 0.001 Bitcoin. He hit send. It's not mine immediately, as we discussed. I get a little notification, and it says somebody is trying to send you this, but it's not confirmed, so you can keep an eye on it and check back in, essentially. So we're going to talk about what happens behind the scenes after he hits send until the time that it's considered mine.
So before we talk about what happened with our Bitcoin transaction, we're going to go over a little bit about how an actual normal application works. When we say normal, this is just the general way to build a networked application on a phone. Okay. And it's using something called a push architecture. So suppose I'm sending a text message. I have the purple phone. I'm on the left.
Okay. I really love color purple, so I kind of wish that was mine, but
it's a nice color.
Okay. So he's going to send me a text.
Hey. So what my phone does is it sends a message. It sends the hey up to the cloud. And the cloud, in this case, let's pretend that it's WhatsApp. Okay. So hey hits the cloud, and then WhatsApp contacts the destination, contacts the white phone here, and pushes the information down to the white phone.
Yeah, it's like a mailman or woman coming to your door saying, "Hey, I got something for you.
Exactly.
Here is a delivery." It's the equivalent happening to my phone. The WhatsApp server is saying, "Hey, this is for you right now, just this second, from Kevin."
So that means the server knows about Colt's phone.
Yeah, it has to know because it has to be able to tell me.
Yeah. Now, in Bitcoin architecture, unlike a mailman arriving at your door, the way Bitcoin works is called a pull architecture. And this isn't exclusive to Bitcoin, but it's definitely not the standard way to build an application.
At least not nowadays.
Not nowadays. So, with a pull application, I can send a text message. Suppose we're implementing a text messaging platform using a pull architecture. What would it look like? I would send the hey, and I would send it up to our network, pictured here as a globe.
It could be a cloud, though. There's no reason it's not a cloud.
Cloud would be fine. I just want to do different clip art.
But it's a server somewhere, a computer somewhere that recognizes, oh, okay, there's a message here. I'm going to add it to my list of messages or something.
Yeah.
And it's for some person named Colt. But what it doesn't do is push the notification, doesn't push the data down to my phone. It leaves the responsibility to my phone or to any phone to check. So instead of a mailman, think of this as...
But like a P.O. box.
Okay, you could, sure. I was going to say as an annoying toddler constantly asking, are we there yet? Are we there yet? Is there anything for me? Is there anything for me?
Yeah,
over and over and over.
Like
That's what my phone is doing. My phone is going to check. Is there any messages? Please. Message, please. Any human contact.
Has Kevin texted me yet? So Colt's phone would look at the actual cloud, reach out to the network itself, and check whether or not there's a message. So in this case, it would see the message to Colt, and voila, hey.
Right.
So to the end user, it still looks like there was communication between the two phones, but there's a difference between the push and the pull. And that's really what's going on in the Bitcoin network. The cloud in Bitcoin, one distinction here is that this cloud right here doesn't need to keep constant track of where Colt's phone is. The cloud and the application just works in a way that you trust that the recipient will come get the message when they need it.
Yeah.
That's what's going on in the Bitcoin network.
So revisiting our transaction. In this case, well, you're sending me 1.5 Bitcoin apparently.
Yeah, and I had 8 Bitcoin in this case.
Wow, that would be nice here.
Feeling generous.
So he scans my QR code. This is the transaction happening, right? Then what happens? He clicks send. Then that is not the end of the transaction, as we've discussed. That's just the very beginning, honestly. That's kind of like the request for the transaction. And the first thing that happens is that Kevin's phone broadcasts the transaction to nearby miners. That's what the app does. It says, hey, Kevin, nearby miners, this address, which is Kevin's address, wants to send 1.5 Bitcoin to Colt's address. Of course, it doesn't say Kevin and Colt, but that's easier to talk about. So that would look something like this. Goes to the nearest miner that we can find. The app, these apps may go to more than one miner. I don't know exactly how they work.
I think in general they try to connect to 8.
Okay, so they connect to some number saying, here's the initial thing, go tell all your friends. And so that's the second part. Miners then relay the transaction to more miners. So here we go. Propagation, our favorite word.
I worked very hard on these. I like these a lot.
That's nice.
It's a good color, purple.
Yeah, purple's great. Okay, so this transaction now, it's spread across the globe. And unlike that game of like telephone or something where things mutate, you know what I'm talking about, where you whisper or something?
Yeah.
The point is here that these are computers and it shouldn't change. It should be the same across all of them.
I think it's pretty accurate.
So then the final part, and this is important, this takes some time. When a majority of the network accepts the transaction and saves the block, what that actually means to accept it and save the block, we'll get into much later not much later, into much more detail later in the course. But just know that there's some conditions that have to be met and some work that has to be done. But once the majority of the network does that, the receiver considers the transaction complete. But I never get any sort of notification or anything that appears on my phone that just from the network saying, okay, you're done now. Like that transaction is done. It's up to my phone to check, to pull, yeah, and say, hey, did that transaction, is it by any chance considered done yet? Is it still pending? Was there a problem? Is Kevin an absolute liar and he doesn't have those funds? What's going on? It's up to the phone to check, or it doesn't have to be a phone, but it's up to the individual person to check. And we have a little slide to show that. I got ahead of the slides, but you can see the phone is broadcasting up, hello, is there anyone out there? Do I have a transaction that finished for 1.5 Bitcoin to me? And you can see that the total updates. I now have 1.5 Bitcoin because, yes, the transaction was considered finished. Okay. So then, a common question. Does my phone need to be on?
No, it doesn't. That's because sending Bitcoin is just adding a line to this ledger, and it's really up to the recipient to check when they need it.
Right. So
Going our Dropbox analogy, somebody puts the Bitcoin into your Dropbox, and regardless of whether or not you're there to see it deposited at town hall, town center, or onto the blockchain, it's still there. And it belongs to you. Nobody can take it. So your phone can be off. You could be hiding in a cave. It's still going to be yours. You're the only person who can claim it when you do ultimately want it.
remember, nothing is actually sent to my phone. The app doesn't receive anything. All the app is doing is looking to this public list and just checking, hey, is it on there yet? Is it good?
Is it good?
Yeah,
Is it there yet?
it's kind of a weird concept when you think about it, that there's nothing actually being sent to my app itself. I'm just adding it to this public list that anybody can look at, including my app. All right, so that's a rough overview of what happens behind the scenes between the time Kevin hit send and then the time where I actually consider the transaction done. All right, welcome back. So far in the course, we've talked about the terms mining/miners. We've mentioned that they exist mainly in this context. We've shown you a picture of a map with a couple of different ledgers, and we've talked about how rather than having one single centralized ledger, we spread it out across the globe. We have these different people, these miners is what we call them, these machines that are in charge of maintaining the ledger and keeping it in sync. So the picture actually looks something more like this. Currently, there are, 10,494 nodes that this website called BitNodes is recognizing on the network. So each one of these is a miner. So, what island is this on? Oh, Bermuda. Okay. So there's one on Bermuda, for example. And then in certain areas, that you would expect probably, like in the denser parts of Europe, there's a bunch of miners and they're all pretty close together. But generally you can see they're distributed, well, actually I wouldn't say it's very, very evenly across the globe, but they are all over the place overall. There's miners in every continent. Well, actually, I guess not every continent. I doubt there's not one in Antarctica. Nope.
Not yet.
Okay, so every other continent. Okay, so that's all that I'll show you on this webpage. There's a bunch of miners. You can explore them if you're curious. So we've seen that there's a ton of them. What do they actually do, Kevin?
So Bitcoin miners have three main responsibilities. The first, which we've gone over, is storing the ledger. So that means storing the entire history of all Bitcoin transactions.
All the way back to 2009.
All the way back to the first one.
How many transactions is that roughly?
So as of April 2018, there's about 300 million, and that means that the entire ledger is about 170 gigabytes. So it's quite large.
Okay, so they store the ledger, and all that really means is that as a new transaction comes in, this is the slowest animation. No, it's not good. Okay, so this is obviously a simplification of what the ledger looks like. There aren't people's names on there, remember. It's just these addresses that are much uglier and scarier looking. But at the end of the day, it's the same idea. It's a bunch of transactions. 170 something gigs, you said, right?
170 gigs, yeah.
Okay, so they're responsible for not only keeping it, but also telling each other about transactions.
So the second responsibility is to relay transactions. And that means when somebody broadcasts a transaction on the Bitcoin network, it'll probably hit just a few miners. And each miner on average is connected to about 8 others. And that means when a miner sees a new transaction, they broadcast that to the 8 miners that they are connected to.
And do we have a slide on that? There we go.
So what's that look like? So this bottom left is a wallet app sending Bitcoin. It hits a nearby miner, that hits a nearby miner, and voila, it propagates across the network.
Across the entire network.
That takes usually 10 to 15 seconds.
Right. To get to all 10,000, whatever it is, 490 something right now?
Yeah, minus a few stragglers.
Right. Well, and also, we haven't talked about what happens if they disagree or there's a problem.
Oh, we'll spend plenty of time on that.
So it's not always smooth sailing. It's not always that everybody just fully agrees on something.
But in general, most of the network is accepting the same transactions. They're all running basically the same software, adhering to the same protocol.
Right.
It's not that often that the miners
But
disagree.
an interesting thing would be, so you said it takes 10 to 15 seconds roughly to propagate. Imagine that I'm on one side of the world and I somehow am on the other side of the world too. I have 2 devices and I'm spending Bitcoin from the same address.
Yeah, that's called
and
a double spend.
I'm spending all that Bitcoin and I'm close to, let's say, Japan, and then I'm close to somewhere in the middle of the US. Well, the nearest miner in Japan is going to start telling all the other miners, hey, Colt just spent all of his Bitcoin from this address. But then the miners closest to me in the US are going to say, hey, Colt just spent all of his Bitcoin sending it to this place. And then they're going to meet in the middle somewhere and try and tell each other about them. And there's going to be a problem.
Yeah. So what miners will do is they will just respect the first transaction they see.
Okay, so we will talk a lot more about what happens when there is a disagreement.
Yeah,
but that's one of the responsibilities.
That case is called a double spend, and we're gonna cover how the network actually deals with that and how that's prevented.
Okay, so along with storing and relaying the transactions, one of the main responsibilities is verifying the transaction. So that means things like, does the sender have sufficient funds? And how would we know that? Well, if we have a ledger, remember, even if it's just a history of transactions, it never has the full balance for a given user, we can still calculate it. So if a miner has the ledger of 1.7 or 170 something gigs of transactions, we could easily just go through and total up all the transactions to and from a given address, like we could here, right? We can see
simple example
here. Who is this? Kilgore starts with 5, sends 5 to Billy, then Billy sends 3 to Montana.
At which point Billy has 2, Montana has 3. Then lastly, Montana sends 2 to Kilgore. So just from the information in the ledger, you can derive the balances of every account, of every address.
So what the miners are actually doing is slightly different, but the idea is the same. They can verify that a given address has the Bitcoin it's supposed to have that it's trying to send. Right? So I can't just say, oh yeah, I'm going to send Kevin 10,000 Bitcoin when I only have 0.5 Bitcoin in a given address. And that brings us to the second way that miners verify transactions. They check if the transaction is authentic. So what does that mean?
So when a miner receives a transaction, they need to verify whether or not the actual sender has sanctioned the transaction. And back to our Dropbox analogy, a miner needs to verify that the sender actually has the key to unlock the Dropbox. Remember that everyone on the network can see what's in each Dropbox.
Right.
It's just a question of whether or not the creator of that Dropbox is actually given permission to release the Bitcoin associated with it. The miners actually perform that verification. If you send a false transaction, if I say, for example, try to spend Colt's Bitcoin, I won't be able to produce a valid key for his Dropbox. The miners are going to see that invalid key and signature, which we'll describe later, and they're going to reject my attempted transaction.
Right. Yeah, remember that an address is something that anybody has access to. You can look at the blockchain. We can see, and we could go back and find an address that has a crazy amount, 19,000 Bitcoins in it, for example. We were just looking at one a couple minutes ago. You can see that address. So there's nothing stopping me from trying to spend that Bitcoin. I can say, oh, I'm sending, remember that a transaction is basically just an address from and an address to and an amount. So I could try and falsify a transaction and say, oh, this is mine, this address, copy that over, pretend to send it to Kevin. But that's not going to fly because miners are going to very quickly realize, yeah, you don't have the private key for that. And so that's a really important thing that miners are doing, obviously, because if you could just spend anyone's Bitcoin all over the place, that would not be good.
No, sir.
Okay, so then the last thing we should mention, this seems like basically it's kind of a lot of work on if you have a computer running. I mean, just honestly for me, just storing 170 gigs on my computer, that's precious real estate. and that's not to mention the fact that these miners are running nonstop and they're actually doing more than we told you about. We'll explain later. But it all comes with a potential reward, which we've already introduced earlier on. The third way of getting Bitcoin is by being a miner and earning it.
Yeah, they're rewarded for doing these 3 responsibilities you get paid for.
Right.
And the question that a lot of people have is, oh, can I start mining? And
you could.
Anyone can mine, but to be honest, it's a little bit late. Because as of right now, if you were to run a 2018 grade laptop all year, 24 hours a day, then you would probably earn less than a penny. And that's in a year. And that's because what's going on is there's now specialized hardware that does exactly these 3 things. And it's much more efficient at performing the actual tasks that a miner has to do than, say, a general purpose laptop.
Yeah, there are these massive warehouses, and I've at least seen some photos of the ones in China.
Yeah.
Where they're like, it looks like they're like half a mile long of just computers, these servers that are, all they're doing is mining. and making a lot of money because they are specifically made to mine and nothing else. They're not made to browse the internet. They're not made to play games on. They just mine.
No, it's an economy of scale. The people who are buying these devices, they're called ASICs, ASIC. The people who are buying these devices are buying many of them, and they're expensive if you buy just a couple. But if you buy 1,000 or 10,000 of them, they get cheaper. The price goes down as you get more of them. And also, if you have access to cheap energy, these devices consume a lot of power. If you have access to cheap energy, for example, in China compared to in San Francisco, then you're going to run a more efficient mining operation.
Right. Anyway, so we actually have a lot of content on mining, on how it works, how miners are rewarded, how it's determined who gets a reward, all of that stuff. We even have a couple slides on ASICs and some of the things that we already brought up. But all of that is to say that, yes, you could get into it today, but it would not be very lucrative unless you're already in a very solid financial situation. You have a lot of resources at your disposal, in which case, you could totally make money doing mining if you're a billionaire.
Yeah, there's also mining opportunities in the other currencies.
Yes, absolutely. So what's happened with Bitcoin, I think, has been a bit of a cautionary tale, and people are not. It was never intended for there to be these conglomerations, these massive warehouses of
devices
miners.
that are specific.
It's supposed to be spread across the world, and it's supposed to be not concentrated. There's not supposed to be any sort of centralized, group, and it's not. It still isn't centralized. But mining itself has become sort of an industry, and there are other cryptocurrencies that have attempted to solve that. We'll talk about later, but they make it harder to game the system and to spend a lot of money in order to make more money.
Yeah.
All right, so that's a rough overview of mining. Next, we're going to dive into cryptography, figure out where that crypto part comes from in cryptocurrency.